Sounds good.
Hello everyone, so we are back to reviewing some APIs, and hopefully today we are actually able to finish the backlog. That would be nice. There's a very high chance that we are able to do that.
Yeah, we did finish it last week as well.
So we keep finishing it. All right, so who wants to talk about this? I guess that's Steven.
Yeah. So this API on regex, we've talked about it in the past. Basically, regex has this regex options.compiled mode, which takes the regular expression and uses reflection emit to spit out an in-memory IL processor for processing the regular expression. We have that. That's worked in .NET Core since .NET Core 2.0. That's great. This takes that same IL and saves it to an assembly. The idea being that you spit out, you have a tool that uses this to spit out an assembly with all of your regular expressions pre-compiled, and then your application can reference that assembly. This has never worked on .NET Core. It throws platform not supported exception. Not because we can't emit the IL, we can, it uses the same logic, but because it requires saving the assembly to disk, which .NET Core lacks support for. We've hemmed and hawed about whether to obsolete it or wait for maybe one possible day assembly builder.save coming back. But at this point, whether or not it does, for .NET 7, we now have a regex source generator checked into main. So we can now spit out C# code as part of your assembly, which largely obviates the need, or replaces the need for compile to assembly. You not only can spit out these in your assembly, but it's nice to read C# rather than IL. So at this point, not only is it not implemented in throwing platform not supported exception, but the reason for it to exist largely goes away. And I think we should at this point just bite the bullet and obsolete it.
Amo, can you magnify 1 or 2 points?
Oh, sorry. Of course. So, yeah, I think I have no concerns with obsoleting them, but just is basically the source generator 100% compatible with the behavior of those?
It is the IL translated back to C#. It is meant to be 100% compatible with the existing engines. It doesn't spit out exactly the same thing that compile to assembly spit out, but it is 100% compatible from a regular expression processing perspective. Compile to assembly spit out like you can pass a name to compile to assembly, and it'll spit out a type with that name, which you can then instantiate. And the interface to get at the generated code is a little bit different, at least how we currently have it defined with the regex generator. You basically define a partial method that returns regex, and it generates a type behind the scenes, and it returns an instance of it. So it functionally, it's producing the same code, essentially, or better code than this did, but with a slightly different way to access it.
What about the ones on, I mean, don't we have other methods similar to this compile to assembly on, I don't know, where was it, app domain or dynamic assembly or something? Are they already obsoleted as well?
I'm not sure which ones you're referring to.
Let me check. I thought there was some on app domain. Maybe I'm misremembering that. Or maybe there was just dynamic assembly. Like I thought we had other. Maybe it's on CodeDom. Maybe that's what I'm thinking of.
I mean, there's assembly builder dot save. Is that what you're thinking of?
Yeah, I mean, basically there's multiple ways, I think, where we have APIs similar to compile to assembly, where basically we persist an assembly to disk. And it seems like we should probably obsolete them all. I mean, I think like I think I talked to Jan about this like 4 years ago, and he basically said I never want to support them on .NET Core, right? So it's probably safe to say that we never bring them, right? similar to how we said, we will never bring those either.
Yeah, I guess I would have to see the API in question. There's a question in the chat, but could the compile to assembly not also be used at runtime and the source generator only at compilation time? I mean, you can use, well, you can't use compile to assembly at runtime in .NET Core because it throws platform not supported exception. On .NET Framework, you could use it, it would spit out an assembly, and then you could assembly.load the assembly, but you can also just say new regex, regex options.compiled, and you end up similarly with an in-memory implementation. You can also, if you want to, you can emulate the generating of multiple of these in an assembly by just having some code somewhere that generates a CS file with all the regex generator attributes, and then compile that, and that will spit out the the resulting assembly. So compile to assembly seems inferior and non-functional.
Yeah, I mean, so specifically because this method doesn't work in core, and we're only going to obsolete it in core, and the message would be, we have a replacement technology, look at the source generators. Like, I think that this is distinct from anything else that is RemoveAt-like. And the other things we can all decide that we're going to do another bulk obsolescence on, but that's a different message of this technology does not, like, this does not function and we have no plans to make it function, stop using it. This one has a workaround, so I think it's a distinct message.
Yeah, for sure. I think they will not be in the same category, right? Because as you said, the replacement or the action taken by the user would be different, right? Yeah. It's just a question of if we are basically saying that we don't want to persist, then it seems like it's something we should generally probably obsolete.
Yeah. As for obsoleting the regex compilation info class, I feel like we've decided that obsoleting types is painful, and instead we just obsolete the constructors.
Well, the reason why types were painful was because you didn't have the diagnostic ID, right? Now that you have it, it's fine.
Fair enough.
I mean,
we can also choose not to obsolete regex compilation info. It's not harmful. It's just a state bag. But the only reason you use it is to pass it into compile to assembly. So I figured you might as well lump it together.
Yeah.
Yeah.
I would probably just put them all in the same bucket and say they're all obsoleted for the same reason. And then remind me again on obsolete, do we always have to provide a message? I think we do, right?
Yeah, we can provide a message that basically steers people to regex generator attribute or something like that.
Okay, let me just so what about this? Oh, great.
I don't know. I feel like our normal messaging tone would be compile to assembly is no longer supported, period. Please use da-da-da, but I don't care.
Yeah, I assume there's some flexibility in the text here, and
Yeah.
this isn't exactly what needs to be there.
It's just like, you know. Yeah, I'm not married to the text.
Yep.
The key thing is that they all get the same diagnostic ID, right? That's
fine. That makes sense.
Yeah.
And we follow whatever the standard practice is for reserving the next one in our list.
Yep. Alrighty, then 4 APIs killed.
So this one keeps coming back because I keep raising questions about it. Sorry. I think last time, if you scroll to the bottom, yeah. So last time this body approved an ObjectDisposedException.throw method, and a PR got opened that employed it and rolled it out and used it in like 200 plus places, which is great. But every single one of them, with the exception of, I think, 4 out of the 200 something call sites, were of the form if condition throw.
Right.
Which begs the question, should we actually have, in addition to or instead, a method throw if that takes the condition and makes it even, you know, more concise?
Is this something that we should generally do as a pattern if we add throw helpers? Because I mean, it seems like exceptions almost always in the category where you have if condition throw, right? I mean, you never really throw unconditionally, you know.
I mean, effectively, that's what we did with argument null exception, right? We added
Right.
argument null exception throw if null, which sort of has it built into the concept, right? You're passing in the value and you're testing if it's null and you're throwing if you are. For, you know, for object disposed, typically you're testing to see if it's disposed and you're
Right.
throwing if it is. So yeah, it seems like in a lot of these cases, there is some condition you're checking for. Like if we were adding one to argument out of range exception, presumably there'd be a set of overloads for the common cases of throw if out of, you know, throw if less than, throw if greater than, throw if not between, you know, whatever. I think the question would be, I think it makes sense to add this. I think the question would really be, do we want to do it instead of throw or in addition to throw? And I kind of feel like it should be instead of, and for the rare case where you actually just want to throw unconditionally, you can use the constructor.
Yeah, it was
But
Or pass true. Or you can just write true.
Right, or throw if true. Yeah, there you go.
I guess that's true too.
Yeah, I think that doing throw if we get a lot of feedback of people saying that, you know, they're throwing object disposed exception as a result of being in a catch, so the fact that they're in the catch block was itself the condition, and that they're passing true, and they're doing it a lot, then we can add the throw. But I think adding both right now, we don't have reason to have the unconditional one given the conditional one, and having 2 ways of doing it, I don't know, just confuses people.
But presumably we would do it for just the time, like just the, I mean, for both.
Oh, no, replace all the throws with throw ifs. I just doodled.
I see. So then, like this then. I guess we need to move the does not return attribute, right? Because now
right, because it's now does not return if on the parameter. Looks good to me.
All right, then let's do this.
Thank you all for entertaining my repeated sending this back.
Yeah, I don't really envision another round after this one.
I don't think so either. I think this should be good enough. But I mean, that's the great thing about having a large code base where you're both adding the API and rolling it out through it, is you get to validate whether it makes sense. I think this should do it.
And the fact that now both static throws we've added on exception types where conditional means I think now that's probably the place that we would start going forward, to Emo's point.
Yeah.
Does anybody understand the question in the chat?
Maybe it means including it in the exception. Like ObjectDisposedException has a public property that returns the instance. I'm not sure.
Or that it should be public static object throw if bool object, but that's weird. The instance we expect to be passed should 9 nines be the literal this.
My var.throw if my var.isDisposed. So this is this would be an extension method on object. That makes sense, right? Never mind. Okay.
Yeah. I mean, it's I think what he meant by this, like throw if would return the exception that it's constructing, but it would never do that because it, fundamentally doesn't return, it throws, right? So.
As for stack trace hidden, the PR, the runtime team pointed out, we don't actually need it in the ref, so we don't care here. It's implementation. It's a runtime only implementation detail, and I forget which way we decided.
Yeah, I still don't understand why we wanted on only one of them, though. Like, it seems like the argument, I understand that you want balanced stack traces, but that seems, I don't understand why you want one differently from the other. Like, that's...
I think that in the PR, they did decide to put it on both.
Okay, that makes more sense now. Okay.
When I copied the proposal in, I was just copying it the way that it had been in the PR at the time. So.
Okay, sanity restored. Okay, no idea what that is. I guess, Steven, you marked it probably?
No, you did. This is the one you're pushing.
Oh, that's the one. I see. Okay, so I think we are still waiting. I'm apparently not good with remembering stuff from 3 days ago. Yeah, so I think we can probably wait for Mark's data, right? I think he's still gathering it, right?
Yeah, I think that's a good idea.
Yeah, so we can probably skip this one. RemoveAt insert to IList by using index struct. I guess this was Christoph's.
Yeah. Are you still here, Christoph?
Hey, yes. So basically we have we already can use the new C# syntax with the caret number on like many like indexers, but seems like we've missed like a couple of members, like RemoveAt, insert, and I've actually just found like a couple of more members, like insert wrench, and also on the iCollection interface. We actually could do that on the iCollection interface rather than just IList. So this is basically kind of like a leftover work for the index struct addition, I guess.
If we're going to start adding, I mean, I think there's a lot more than just these two.
Yep.
On top of which, just having these on the interface but not on the concrete types means we're actually making these index types even more expensive, forcing people through interface, through extensions, through interface dispatch rather than just direct calls. It would be great to have an end-to-end proposal of, okay, if we're really going to embrace adding index overloads, like what would the complete thing look like across all of our types?
Would you suggest to add it to both as the extension method and the instance, or just the instance?
I don't know. I mean, I wasn't saying we have to, but like.
I mean, it kind of makes sense to add them to both, but like, so kind of let's maybe talk about it a bit more, and then I will suggest to the person to update the API proposal, and you can bring it up again, I guess. So my kind of thoughts are probably like it makes sense to add to both, like in case someone have already implemented the iCollection themselves and they are not necessarily using any of the built-in collections, they will also be able to benefit. But on the other hand, like, yeah, I mean, nothing is preventing them to also implement the another overload, I guess, to be.
Yeah, well, I mean, aside from the fact that I haven't finished writing down the places that Eric T did some research to find out what are the ways that DIMs are going to be dangerous in the runtime, as far as evolution and runtime compat is concerned. Like, if we had confidence in DIMs and knew how to use them correctly, this seems like it would be better for DIMs because then you can override it at the type. So
Yeah,
I think we're
what would you
looking
do-
at our natural. We don't know what the difference is between an extension and a DIM going forward, aside from the fact that we're scared to use DIMs.
But
At least I'm scared to use DIMs.
But what would you do more efficiently? Because fundamentally, all that this thing does is just the computation of the end. Like if you have already taken int, like it's a pretty straightforward thing, and so you, in both cases, you still pay the cost of the vtable dispatch, which is really I think the primary concern. But if you had a concrete type, I think the implementation of this method is always going to be identical.
I guess that's true depending on what the tooling for DIMs looks like, because it would at least inform you that you might get a benefit from specifying the thing. Though I don't remember how they work. If it just lifts it to the method, then that would mean you get it for free, or lifts it to the type.
Yeah, I guess my point is if it's an extension method over the interface, I think the efficiency will be the same no matter whether it's a DIM or not, because the implementation will be the same, and the difference is just do you do a vtable dispatch to the one that takes an int, or do you a vtable dispatch to the one that takes the index, right? But then, like the actual content of the method will always be, subtracted from count and then index into it if necessary, right? Which is trivial. I think the only benefit you would have is on the concrete types, because then you just avoid the entire interface dispatch to begin with. And then, presumably the method could be inlined, and then, good things can happen to you. But I think if you, so in that sense, I don't think these are great candidates for DIMs, even if DIMs would work. It would be more interesting for things where, the implementation could optimize something differently based on the data structure, right? But that seems.
Yeah, well, I mean, it does depend on how the methods get lifted into the types and what the compiler writes down when calling it. Right. So like a sealed type that implements an interface, it would know that would be the actual method, so it could use call instead of callvert, etc. But right. I don't know how much of the smarts of that are in the compiler versus the JET.
And often for extension methods, efficiency is sort of can be a secondary concern, but here we're talking about a representation for an index into a core collection. That seems like something we need to care more about from a design perspective. The other thing to consider, like we had this exact same concern when index and range were initially introduced, and we worked with the C# language design team to special case indexers in particular to basically say, if the thing has a count property, then the compiler actually does the math to translate the index into an int using various things, which is why we don't have a bunch of index-based overloads on our core collection types, because we get it for free. It would be interesting to think through if we actually start seeing a need for this in a whole bunch of other methods, and we'd have to go add another 200 overloads of insert and RemoveAt and find by and whatever else. Like, what would a compiler feature look like that allowed indexes, hat1 to be passed in more places?
Yeah, that's actually a very interesting point of like, could we get like an attribute that says this is an indexer attribute, and then we just change IList insert to say the index parameter is an indexer, and that now we can tell it that it understands how to do the automatic transform of count.
Right.
Yeah, I think the compiler. I think when I had this chat with Jared, I mean, he wasn't opposed to that. It's just that they wanted something that did the job at the time. But I mean, it was understood that if we want to extend this to like other methods that also take an index, that would be fine too. We would just have to sit down and design it.
Yeah, if only there was a member of this group and the C# language design group.
Well,
for those who can't see me, I have my finger on my nose.
Well,
since your camera's not on, no one can see you.
I can see me. I don't know. It just feels like, if we were only talking about two methods, fine, ship the two methods. But I feel like we should do the work to figure out what the complete picture looks like, because I think it's probably across the stack a whole lot more than two methods.
I agree.
Makes sense. And would it make sense to just add the extension methods and figure out with the meantime, kind of figure out with the Roslyn basically if they can optimize this particular scenario rather than adding?
I mean, it would be
everywhere first.
I don't know. There's a document that Jared wrote where he talks about how the compiler does the lowering. And it would probably be good if one of us could just take a look at it again, because I already forgot how it works. But I think it's basically just for the indexer itself. It doesn't really extend to any methods. But it would be interesting to figure out what a design would look like, right? Because it seems weird if we would have to keep adding methods. It might be better to just say, hey, what if we introduce an attribute, put it on the parameter, and then the compiler can do the rewriting logic like they do for the indexer, right?
Makes sense. So you would put the attribute on the end index essentially.
Right, but I think, like, to Steven's point, like it's a function of how many places do we need to do this, right? If it's 4 methods, then sure, let's just add them to the BCL rather than have the compiler rewrite it. But if it's, oh shit, now it's 50 or 60 or 100 or unbounded, then well, let's just change the compiler to deal with that, because then it's we do it once and then we're done, and then it's just a bunch of attributes that we have to potentially apply to parameters. But that seems less problematic.
It feels like probably the right answer for this is to take all the ref CSs and look at all of them for any parameter named index, IDX, anything else we can think of, because certainly like array.copy, right? It has some indexing parameters, and we could add index-based overloads for those, or we could figure out an attribute that says it takes an index of the parameter named whatever. So I think the complete picture requires looking at all parameter names and hoping we can figure out all of our naming patterns.
Yep. So would the follow-up be also for the API reviews, or would that be like some kind of more like an internal conversation, then we would come back with the solution basically here?
Yeah, I think that would be good. I think when we had this chat back then, the concern was the compiler would have to do some heuristic, right? Where they would have to say, oh, if the type itself is indexable and the parameter name has index somewhere in it, we apply that. But then they felt like that can result in a lot of false positives, right? But that's probably the exercise we should be doing, to Jeremy's point. Just search for everything that has index in the parameter and then just see, how many things would we actually apply this potential attribute to, right? Because if we don't do the attribute, then, well, those are the particular things they would have to add overloads to, right? And then that's easily in the, 60 to 100 probably.
Makes sense. Okay, so the follow-up action is to figure out all of the places, and then based on that, kind of we make the next.
Yeah.
Yeah, I think there are a variety of
outcomes
possible. We could end up deciding, you know what, while this is core, like it's not core enough to care about the interface dispatch, and so let's add it to a few interfaces, and that'll get 90% of the next thing that we care about, and we'll call it done. Or it could be, wow, we, of all the places we would actually want this, well, we really only want it in 10 places, so we just go and add those 10 methods. My gut says we're going to see, in reality, there's like as the numbers Emo was throwing around, 50, 100, 200 just in .NET runtime, never mind the rest of the ecosystem, at which point we should be thinking about how can we just have this all happen automatically via a language feature.
Yeah.
Yeah.
I mean, my gut feel is in general, like once you start using this index syntax, it's this long tail, right? Even if we say, oh, we only care about certain things, if you start using other overloads that take indices, right? I mean, you generally want this feature to work everywhere, but there really is no reason why, oh yeah, this index is special where we don't need the syntax, right? It's just, nobody cared about this yet, but.
Right. And just as with nullable, I feel a whole lot more comfortable doing the exercise of going through and adding an attribute to parameters saying this is an index into this, or this is an index into this other parameter, and just layering that across all of our collections, and third parties can do that as well, than I would about going and adding just a bazillion overloads.
Yeah, I think the interesting place where we'll have to decide, do we care for the index type, is places where we took like an array and a start and a length, and we say, well, we added a span overload, so use that one instead. Like we may decide we don't want to paint those, but if we do go an attribute model, then we would probably do it just for consistency.
Yeah, that would be my argument. It's because moving from this to span is potentially way more work than just
right. But in deciding like what's the actual cost, right? It'd be like, well, for array dot copy, granted you can just use span copy too, but so some of the things we've spanified, and some of the things we maybe haven't or can't because it's collection, or I guess list. Collection doesn't have notion of indices, and so when it comes down to, if we had the attribute, here's how much work we would do, and if we didn't have the attribute, here's how many extension methods we would have. I don't think they're going to be the same number.
That's fair, but that's, I think, part of the concern that I have is like the problem really is like it's in the eye of the beholder, right? Like, I mean, conceptually every index should work with the C# syntax, right? It's just that we may not care enough to provide the overload because it's expensive. But if it were an attribute, then there really is not a reason why we wouldn't just apply the attribute, right? And so that's why, yes, you could say that, oh, it's 20 methods versus 200 parameter attributes, but arguably one of them is the better outcome. Because it is kind of fundamentally like a type system thing, as Steven said, right? Similar to nullable, you just expect it to work everywhere. And like every area where it's not, it's arguably a bug. It's just nobody cared enough to fix it, right?
Yep.
All right. So I think we're at time, unless somebody has something else. Nope. Then thanks everyone.
This whole mode of continually getting to the end of the backlog is quite satisfying.
It is. I mean, like, I think that's kind of the if you look at our distribution over the year, there's always this area where like a lot of the feature work is happening, and then we spike, and then we plateau out again. So and now we're at that time again.
Yeah, well, the problem will be when we hit November, December, and we stop meeting because too many people are taking time off. That's also the same time that people finish putting forth their ideas, and then we'll go back to 9 months of not finishing.
Pretty much. But like, I don't know. To me, that's just the reality of product development. I don't mind.
Yep.
All right. Then see you guys next week.
Yep. See you.
Bye, everyone.
Yep.
Bye.
The gavel. I keep forgetting it.